So while I was adjusting everything last night, I noticed that the audio frequency would vary pretty radically over time, like almost 100 hertz. And so I've set up some logging here to try to figure out what's going on. So I have a whole bunch of taps. This probe here is getting the local oscillator, the primary local oscillator, which is a voltage controlled oscillator. And these taps are going in the multitester here and are measuring the input voltage to the voltage controlled oscillator. This probe is getting the beat frequency oscillator for receive, which is mixed to down convert the intermediate frequency into the audio frequency. This probe, as before, is getting the audio frequency. And then additionally, I've even got the second output on the signal generator going into input 4 on the oscilloscope so that I can monitor the frequency being fed into everything. And so the test is the same as before. I've got 7.020 going in. And I'm using the data logger on the oscilloscope here to measure all of these different frequencies. The trace 1 there, the top, is the local oscillator, which is 23 megahertz in this radio. Trace 2 is the beat frequency oscillator, which is give or take 16 megahertz in this radio. Trace 3 is the audio frequency coming out, and I've actually turned it up to 700 hertz, which is my preferred frequency. I noticed when it was drifting that the IF filter has a good enough response that 700 hertz is fine. And then the bottom trace is the input from the signal generator, which is surprisingly noisier than I would have expected. Now, I think a lot of those little dropouts there are just reading errors, probably because of the probes or however I have it hooked up. But you can see that the audio frequency is actually not doing too bad right now. I mean, it's plus or minus 17 hertz. It's actually better than that. And then looking at the voltage going into the voltage controlled oscillator, and it's changing a little bit. Let me see if I can get this to the point where you can read the statistics. So the standard deviation is some tiny amount, and the span is one millivolt. So it's actually fairly stable. I mean, it's a four and a half digit multimeter, so it's reading out pretty far. So I'm not sure what was causing what I was seeing last night, because it doesn't seem to be happening to the extent that it was. When I logged it overnight, it went all the way up from 600 to almost like 750 hertz, and then it kind of peaked out at 750 hertz. But I guess I'll let this run for a while, and we'll see if the problem comes back, and if it does, maybe there'll be some indication of what's going on. Here's a screenshot of what it logged overnight. You can see over the course of 6 hours, it started right around 605 hertz. That's the bottom trace there, and it had gone all the way up to 728 before I shut it off this morning. The top trace in this case is the amplitude of the audio frequency, and you can see actually the amplitude is higher up around 700 hertz than it was around 600 hertz. So that's why I decided to go ahead and increase the side tone, or not the side tone, but increase the CW offset frequency. Okay, so this has been running for almost 2 hours now. And you see there's been, if you look at the third trace, there's been some variation in the output frequency. Interestingly enough, it went down, and now it's going back up. From watching these numbers, my guess is what's happening is the local oscillator frequency is changing. And if you look over here at the voltage, it has been varying slightly. I mean, that's what, 6/10 of a millivolt. My 4.5 digit multimeter here may not be sensitive enough to really see the change. But anyway, I'm going to try to export, so I'll stop the data log, and then I think I can put the USB key in and save. Did that do anything? Save. All right, save. Save to external. Type, oh look, we'll do it as a CSV file. And press to save. Sure, that sounds like a good place to save it. How do I tell it to just save? Press to save. There it goes. Okay. Hey look, there's a CSV file now. So let's load that up on the computer and take a look at what the local oscillator frequency was when the audio was at 700 hertz and when the audio was at 600 and whatever it went down to. Okay, so here's the data, the spreadsheet loaded up in Excel. And we can look at the beginning. We were at 694.62 hertz on audio, and our local frequency was at 23 megahertz, 15 kilohertz, 120 hertz. And it's interesting, it appears that the resolution here is about 10 hertz. But I added a formula up here to find as low as we went. And the lowest we went was 688.96. And so compared to our, well, actually, let's also look at what the maximum was. So if we change this to give us the max. Okay, so our highest was 706, and our lowest was 688.96. So let's see at, let's see what our local oscillator frequency was at our highest. So we're gonna do a search here for 706.22. Okay, so our local oscillator frequency at that point was 23015.120, so probably within, and our beat frequency oscillator. So let's copy both of those all the way up here. And we'll make this column a little wider. Okay, and then let's find our 688.96, and we'll grab our values here. That's interesting. This is lower than that. Why did the, oh, whatever. Go over here. And, okay, so the beat frequency oscillator frequency was the same, at least within our resolution of measurement. But then we can see here that the local oscillator frequency was definitely different. So I think what I might want to do now, well, at least within the resolution of what we're seeing here, that points to the variation in output analog or output audio frequency coming from the local oscillator changing. And I suspect that that's because the local oscillator input voltage is varying. This radio kit came with a one-turn 100 kilo ohm potentiometer, and so the tuning is incredibly sensitive. You touch the knob and you've gone a couple of hundred hertz in one direction or the other. And so I don't know if that's related or if it's just a low quality potentiometer, or there might be a loose connection. I think one of the connections to the potentiometer is starting to break from being moved back and forth. But before I change anything, I think what I want to do, the frequency, the signal generator data was not particularly useful in this case. Although I guess we could go find, and we probably should have looked at what that was at 706.22. I mean, there is some variation in the signal generator output. That signal's very noisy because it's such low level, I believe. And then 688.96. Yeah, I mean that's a pretty significant variation in the signal generator output. Although we were still 688.36 here, where it went back more or less to where it had been. I don't think that that's the cause of the problem. I think the cause of the problem is that the voltage is changing. So what I can do is I can take trace 4 here and hook it up to the voltage, and then we can log everything together instead of having to separately log it on the multimeter. And we might get better resolution as well. Well, this might be part of our problem. As predicted, I said these were getting a little loose, and when I went to change the probes, they broke off. So let me solder those back on and get the oscilloscope probes hooked up, and we'll see what happens. Okay, those are soldered back on. I would have preferred to diagnose this without making a change, because it's entirely possible that by soldering those back on, I fixed the problem, because that was the whole source of the variation anyway. But I have it hooked up to the probe, and so now trace 4 there is the VXCO, and I'm not sure if I'm measuring this right. I just used the root mean square, but you can see there it's currently 1.39 volts. Incidentally, the tuning on this thing is, oh my gosh, it's so sensitive. This is a 1-turn 100K potentiometer. I've ordered a 10-turn 100K potentiometer, which may be too much, but I mean, if you look, I'm barely touching the knob, and I'm jumping back and forth. You know, that was 200 hertz right there change. So let's see if I can get this to 700 hertz. It was not easy. I mean, I'm barely touching this knob. If you look, I'm like going like this. I don't know if you can even see the knob moving. And it's, you know, oh, that was 300 hertz. I read someone had put a 10K pot on instead of 100K, but I think you lose some overall tuning range, and it's already kind of restricted on this design, so hoping that the 10 turn will be somewhat appropriate. All right, okay, so we're close to 700 hertz. So let's set up the data logger. Go back to the data logger, we'll do the measure logger, and we'll say start. Okay, so it looks like we have about the same resolution on the voltage, but we should see if it is moving in concert with the audio tone and the local oscillator. And we'll let this run for, I don't know, another hour and see what we get. Okay, well, this has been going for an hour. And the audio output frequency actually seems pretty stable. I think that that slow increase there might be from the radio warming up. It's interesting, the voltage did actually change, and this spike here, I bumped this stuff on the desk and then it recovered. I wonder if I'm bumping into the limits of what I can measure with this hardware. But I'm gonna, without powering it off, save this log and restart it and see, and reset it to 700 hertz and see if it stays stable and stays there. And then at the same time, I can look at the CSV file and see if there's anything that shows up as far as the voltage. So this is kind of cool. I can go down here to display and zoom into the individual traces after I've stopped it. And when I do that, it actually shows me, in addition to having a bigger graph, but it actually shows me statistics. So, right, I can see here that on the audio frequency it was arranged from 705 to 742, and an average of 729. And then I don't know if I can scroll. Oops, you can't see what I'm doing. I don't know if I can scroll it, but it doesn't seem to actually do anything, so we'll put that back where it was. And then I can look at the voltage, and the voltage actually varied quite extensively. If you look at the voltage, it went from 1.3861 all the way down to 1.3587. And surprisingly, now these little dropouts on the local oscillator are annoying because they make it hard to see on here what the actual data is, and that may just be down to the way I'm probing it. But it seems like it was pretty stable, and then the beat frequency oscillator was extremely stable. It was a 2 hertz min max difference, so that's really encouraging. Anyway, I'm gonna go do that additional log and see if once the radio is warmed up, it's more stable. I mean, this could be just normal behavior for this hardware. You know, it's not going to be perfectly stable all the time anyway. Okay, well, it's been logging for an hour, and the output frequency has been remarkably stable. In fact, if I go down and look at trace 3, all right, this kind of makes it look bad because the vertical scale is so large. But if you look, it's ranged from 693 hertz to 706 hertz. That's 13 hertz over an hour. The average is 700 hertz exactly, and the standard deviation is only 3 hertz. I think what I was seeing before was a combination of that loose wire causing some drift, and then also just everything needing to warm up. If we look at the voltage going into the VXCO, it's actually been pretty good. I mean, there's sure a standard deviation of 4 millivolts, but looking at the actual oscillator, aside from those dropouts, right, it hasn't changed very much at all. And then the beat frequency oscillator is like remarkably stable. It had a dropout too, but it really hasn't varied much at all, and you can see that in the data logs. So probably what was happening originally was the voltage was varying through a combination of the loose wire into the potentiometer and just everything warming up, and that was putting the local oscillator slightly off and creating the variations that we saw. But now, once the radio is warmed up, that's really quite good, I think, and better than some of the other radios I have. So there we go. This was fun. The data logger on this scope is really quite useful, and I'm pleased to have gone through this.